So we've talked about vectors very extensively. So you kind of know the basics of what vectors are. Now let's go ahead and apply them into real life. So we won't do a lot of crazy applications, but I do want to give you guys a couple of problems of where you can apply them. Typically, usually there's some applications that can get really difficult, especially when you're like have a box, right? If you have a box inclined at a particular angle, you can have a couple forces acting on this box. So, in physics later on, you're going to see that you have a force going downward, which is basically the force due to gravity. And you have maybe a force, if you're pushing this box, you have a force being applied this direction. And then you have a force being acted by the friction due to this incline. So there's a lot of different things that are going on. And one of the things that we can do is we can find different angles, we can find the amount of force going downward. There's a lot of things that can go on. We're not going to do things that are very complicated like that, but I do kind of want to give you an idea of where these vectors are doing, and we're also with navigation as well. So we'll start off with this first problem. So two forces of 15 and 22 newtons are pulling on a point. So if the angle between the forces is 100 degrees, find the magnitude of the resulting vector. So basically what is going on here is that you have two different forces. So you have this point, you have a force going this way, and you have another force going this way. Okay, so the force going this way has a magnitude of 15 newtons, and the force going this way has a magnitude of 22 newtons. So I said here what exactly a newton is. 1 newton is equal to about 0.225 pounds. So you can kind of imagine how much a newton is. It's a little bit less than, so it's a little bit more than, a little bit less than not even a pound. So, so that's the newton. So a newton, remember, it's a unit of force, and so this is the magnitude. It's a vector. Okay, so 22 newtons is a vector, 15 newtons is a vector. So this is basically the resulting or the magnitude of the vector. Okay, so so whenever I tell you newtons or like 22 newtons, this is basically the magnitude. Oops. So it's the magnitude of the vector. Okay, so that tells you how much force is being applied at this particular point when it's being pulled. So here it tells you that this is 100 degrees. So this guy's 100 degrees. Okay, so what we want to figure out is find the resultant vector. So basically we want to find the resulting vector that's going this way. So we said that the resulting vector is going in this direction. So if you kind of think about these other two vectors, remember that we can grab a vector and place them in another position. So it can be going this way, and you have this other vector going this way. So you, by the parallelogram law. So one of the things to kind of just know is that if this is 100 degrees, then this guy should also be 100 degrees. Okay. So then also, if you want to think about it the other side, so if these two are 200, I know that the whole thing should be equal to 360. So the whole angle should be 360. So this, if this is 100, this should also be 100. So that's 200. Then you have these other two angles that I have here. So this is going to be, I don't know, let's say these are x's. Okay, so that means you have two x's. And all of this should add up to 360. So I can subtract the 200 over. So you have 2x is equal to 160. So when I divide this out, you're just going to get 80. Okay, so that means this guy is 80 degrees. This guy is 80 degrees. Okay. All right, so just to give a little bit of geometry. Now, the thing is you wanted to figure out what is going to be the magnitude of the resulting vector. The resulting vector is in red. So I want to figure out how much pressure or how much force is acting on this vector. So you gotta kind of have to think about it. So if you kind of think about it as in like, well, this guy is just basically a triangle. Okay, so let me pull that out. So this guy is basically a triangle. This guy right here is 80 degrees. We know that this is 22 newtons. Okay. We're not sure what the other ones are, but we know that we need to figure out what this guy is. This guy is a resulting vector. Let's call that R. This is what we want to figure out. Well, what about this side? What is this side going to be? Well, this side comes from the fact that you have this vector over here, which is 15 newtons. So how can we solve this? Well, look at this. This is a side angle side problem. Okay, so side angle side means that we have the law of cosines. So we're going to use law of cosines here. So if you think of the law of cosines, the law of cosines says that I can figure out what the side is by by looking at the other two sides in this angle. So I'm going to have c squared equals a squared plus b squared minus 2ab times the cosine of c. So this c in this case is going to be this r. So you have r squared is equal to a squared, that's 22 squared, plus 15 squared, minus 2 times 22 times 15 times the cosine of 80 degrees. Okay, so let's get rid of this r, so the square, so we're going to square root both sides. So we're not going to add plus or minus because we're looking, the force should be positive. So you want to figure out what all of this guy is. So you're going to take the square root of 22 squared plus 15 squared minus 2 times 22 times 15 cosine of 80 degrees. And make sure that it's on degrees. So what I ended up getting is about 24.4, and this is going to be newtons. So the resultant force that's being applied when a 15 newton force and a 22 newton force is being pulled is going to be 24.4 newtons. Okay, so notice that when doing these applications, you really have to know the geometry very well, and you also need to be able to know how we can apply which tool. So here is kind of your incorporating everything that you've learned in this class. Okay, so now let's go ahead and talk about bearing. Okay, so what bearing is, you need to kind of think about the navigation system. So when you think of the navigation system, you have the north, south, the west, and the east. So this is going to sound really weird because usually when we were doing all the problems in trig, all the different angles, if I have this particular vector or point, all the angles were hugging the x-axis. But when we talk about bearing, bearing is going to be hugging the y-axis, or the north and south uh, region. So if I have a vector going this way, so this would be in the northeast direction. So if I have an airplane that's flying in this direction, in the northeast direction, at a bearing of 20 degrees, what that means is that this guy is going to be 20 degrees. Okay, if I have another vector that's going in the southwest direction, okay, so this is southwest, and the bearing in this case is 10 degrees, then this guy right here is gonna be the 10 degrees. So this is really weird for us because we're so used to having the angle being in the x direction. But when we talk about bearing, think about that as the way that ships and that airplanes tend to like travel. When we talk about bearing, we're talking about the angles that are in the north-south line, okay? So here I give you kind of an example. So see how this is northeast, and you have a vector going this way with a varying of 60 degrees. This is what it's going to look like. Okay, so let's do this. I think this is the last example. No, we have two examples left. Okay, so let's actually do these two problems in the next video so that you guys can kind of, so the other question can kind of simmer down.